Today's lesson is 11.1, Sequences and Series. What is the difference between arithmetic sequences and geometric sequences? So here are notes that you need to copy down. And then there is some more. And here's an example what our graphs are going to look like. So let's take a look at this problem first. Determine whether it is an arithmetic sequence. Well, if we go back to your notes, arithmetic sequence, just a second. Yeah, it's at the bottom here. Arithmetic sequence have a constant term that is being added. Okay, and we call this the common difference. So if we look back here, what is being added to negative 3 to make negative 8? That would be negative 5. Does that work here? Negative 5. What about here? That one's negative 10. So is this an arithmetic sequence? No, because it does not have a common difference. Okay, how about this one? Determine if this is an arithmetic sequence. In this case, we are adding 6, and adding 6. So yes, this one is arithmetic, and we could support that by saying the common difference is 6. Okay, so this one is an arithmetic sequence. So what is the next 4 terms? So that's just continuing our pattern on. So what do we have here? So we are adding 2 each time. So we're at negative 4, and so we'd go negative 2, add 2, 0, 2, and 4. So that's all we need to do to find the next 4 terms. And then that same sequence, let's plot them. So make sure that you've got some graph paper. And then what we do is we plot it with its position. This one is our first term, and so we go over 1, down 8. This one is the second term, so we go over 2, down 6. This one is the third term, so we go over 3 and down 4. And so we continue this pattern on, and that's what our graph would look like. Oh, I had to do 7, so 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 2 extras on there I didn't need to do. Okay, let's take a look at this one. During the routine, a high school marching band marches in rows. There is 1 performer in the first row, 3 in the next, 5 in the third. This pattern continues for the rest of the rows. Use the information to determine how many performers will be in the 20th row during the routine. So we have 1 in the first row, 3 in the next row, 5, 7. Our pattern is that we just continually add 2 more people to each row. So if this is our first row, second, third, fourth. So I'm going to write it out a different way. 1, 3, 5, 7. First, second, third, fourth, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th. So that's the spot that I'm looking for. So now we fill in the numbers to get there. $39 looks to be our answer. So that means there will be 39 people in the last row. Now there are formulas for us to do this, but at this point we're just going to write things out. We're going to get to the formulas in the next lesson. Okay, let's go to geometric now. Geometric, if you go back to our notes here, let's see if I can find the page, means that we need to multiply by a common ratio. So let's see if we are multiplying by a common ratio for this problem. 8 times 20, 8 times what makes 20? Sorry, I made that really confusing. 8 times what makes 20? Well, it's not a real easy one for us to see, but we can undo that, go backwards, and take 20 divided by 8, and you'll get 2.5. So 8 times 2.5 is 20. Okay, well, let's try that again. 20 times 2.5, that does become 50. And how about 50 times 2.5? That is 125. Oh, I keep putting the decimal point in the wrong spot. So is this a geometric sequence? Yes. And then we could support it by saying its common ratio is 2.5. Okay, how about this one? So let's take 30 divided by 19, and that is approximately 1.58 rounded. How about if I take 30 times that last answer? It ends up being 47. The ratio on the next one would be 41 divided by 30, which is 1.36 repeating. So this is no. It does not have a common ratio. Okay, so again, we have a geometric sequence and find the next three terms. So we have to find a ratio first. So 10 times what makes 15? If you can't see that, you do 15 divided by 10, and it's times 1.5. Okay, so we've got the first three terms. Do the next three. 22.5 times 1.5, 33.75, times by 1.5 again, 50.625, times that by 1.5 again, 75.9375. Now with this, I'm going to have you keep all the decimal places. But those are our next three terms. Let's graph them. So graph the first six terms in that same sequence. So again, we graph it with its position. So this is our first term, that's our second term, this is our third term, and so on. So we need to go from 0 all the way up to 76 approximately. So let's determine what we should go by for our scale. I wonder if we could go by tens, and I'm going to skip a line. So 10, 20, 30, 40, 50. So going back again, our first was at 10, our second was at 15. So at 1, we go to 10. At 2, we go to 15. 3 is 22.5. 4 is 33. So 22 and 33. And then we go 50 and 75 approximately. So there are our first 6 points. Okay, determine if this is arithmetic, geometric, or neither, and then explain why. Okay, first thing, let's just see if it's arithmetic. What is being added to 13 to get 25? So that one's being adding 12. Does that continue working? 25 plus 12 does make 37. How about for the last one? Is it plus 12? So it is arithmetic. And then our explanation is the common difference is 12. How about this one? Okay, let's check to see if it's arithmetic first. This one is adding 3. Now we're adding 4. Okay, they do not have a common difference, so that doesn't work. Okay, let's try multiplication. So you would take 5 divided by 2 to figure that out. That's 2.5. 5 times 2.5 is 12.5. So that does not work. So this one is going to be neither. And why? It doesn't have a common difference or common ratio. And then our last problem for the day. How about this one? So we have here that we are multiplying, I'm sorry. Let's do adding first. This one would be subtracting 18. We're not subtracting 18 again, so that doesn't work. Okay, what would you multiply 6 by, though, to get negative 12? Times it by negative 2. This one, times it by negative 2. This one, times it by negative 2. So, do we have a common ratio? Yes, we do. So this is geometric. And the reason is the common ratio is negative 2. Okay, that's the end of the lesson, so you can write your questions and your summaries.